Welcome to Mastering Solutions. This question, I'll be honest, is not really my favorite. They came up with this big, long question to basically try to get you to be more comfortable with some of the equations. That's all they're really doing here. I don't really like it because there's a couple things where you have to extrapolate several different pieces of information, which is fine, but I just feel like it is too difficult for what we're trying to get here for most students. So let me get off my soapbox now and let's go through the question. With this, let's write down the list of information that they give us, and then let's go through it one step at a time. So they tell us that the wavelength that we'll be using is 632 nanometers, and the L, they tell us, is 30 centimeters, 30 cm, so that is 0.3 meters. There we go. Okay. So we have L, and then they also tell us we're looking at M is 1. So M equals 1. And now they also tell us that the D, because they're basically wanting you to understand that the distances between the striations, that is the diffraction grating in this case. So D, we'll be using two of them. It's 1.87 nanometers, and we're using 1.94 nanometers. Now, the part that I don't really like is let's go through the equations that we have to use. Again, like I get it. A teacher would say, well, they should be able to understand it, but I think it's too challenging personally. So we're going to be using the equations y is equal to L tangent of theta. And then we also need to use the theta is equal to the inverse sine of m lambda over d. Now, of course, it's given as sine of theta equals m lambda over d. I just moved the inverse sine over. And now we plug this in for the theta there. And we have to go one step more because they're telling us that all of this is performed in water. And so if you look on the equation sheet and in the book, they tell us that the wavelength of something, you can find it a few different ways. One of the ways that we can find it is the wavelength in a vacuum over the N of the material. And so this that they're giving us here is the wavelength in a vacuum. And in the book, like we said, that we're assuming that vacuum and air are the same thing. So that's why we always just use the lambda over 1. And so we just take the wavelengths given. In this case, it's not. It's different. It's 1.33 for the water. So we have to plug this in here. And so when we do that, what we're left with is theta is equal to the inverse sine of m over nd. Now this we can plug into for theta right there. So that's what they wanted you to be able to get by yourself, which I think is too hard. So to do that though, we're going to use the two minimum and the maximum for the diffraction gratings as the muscles contract. And so let's start off with the minimum. That'll be the 1.94. And so we're going to have, let's see, let's all write this out first. So L tangent of inverse sine m lambda over n. There we go. So when we have L, that is 0.3 meters times the tangent. Then we take the, not 3, inverse sine. And then we have 1 times 632 times 10 to the negative 9 meters divided by 1.33 times the minimum, which is going to be 1.94 times 10 to the negative 6. All right, so 0.3 tangent inverse sine, and then we're going to have 1 times 632 times 10 to the negative 9 nanometers divided by 1.33 times the D is 1.94 times 10 to the negative 6. And that gives us 0.0758. That's in meters. So we go 1, 2, so we'll say 7.58 centimeters. Okay, so that is for the minimum. Now let's do the maximum, and it's all going to be the same, 0.3 meters, tangent inverse sine of 632 times 10 to the negative 9 meters, divided by 1.33 for the index of refraction of water. And now we need to use the maximum one, so it's 1.87 times 10 to the negative 6 meters. And of course, when we plug it into the calculator, we can just steal this. And now we'll just change this to 1.87. Okay. So that gives us 7.88 centimeters. So 7.88 centimeters. So there are your answers for the minimum and the maximum of how much that diffraction grating is spreading as the muscle fibers contract. Or I guess, you know what? They want us to take us one step further. They want us to subtract these two. So it's 7.88 minus 7.58 centimeters minus centimeters. And we don't really need to use a calculator because, of course, it's going to be 0.3 centimeters. And that's your final answer there. That's how much it's spreading. So that, like I said, I feel like was a pretty challenging question and setting up. But if you got it or if you followed, awesome job. And we'll see you on the next question.